In this section, we will be covering public key encryption, which is fast becoming a very commonly used form of data security and encryption. Now, what makes public key encryption both popular and very secure is the fact that it is asynchronous in nature, which means I don't have to know how you decrypt your information. And you don't have to know how I decrypt my information. But you can send me encrypted data without having to know the unlock process. And we achieve this flexible encryption using both public and private keys. And because my decryption method never passes over the network, it would be very difficult for an attacker to steal my information and break into it in a timely manner. But one thing that you need to be aware of is that there is no such thing as true security. Public key encryption has been broken by stealing the information and performing a process that's referred to as brute force. And that basically means try every possible combination of decryption until you finally break it. Now, although this can be a lengthy process, it is still compromising our data. So public key encryption is very useful, even though it can be broken. So let's take a look at this process. Now, both our client and our service will have a private key as well as a public key. Now, the only thing that will ever pass over the network is our public keys. So if client 1 wanted to communicate with client 2, it would send its public key across the network. Now, the only thing that a public key can be used for is to encrypt the data. It can never be used to decrypt it. Now, this is commonly referred to as a one-way hash, meaning that you can scramble it, but you can't unscramble it using the same technique. Now, once computer 2 receives my public key, it will then send me its public key. And then the data communication will start with computer 2 encrypting any data using my public key. And it will pass that over to me. Now remember, as this encrypted data passes over the network, the only way to decrypt it is using my private key, which I keep locked down on my local computer and never allow it to pass across the network. So when that encrypted data reaches my endpoint, I will then unencrypt it using the private key. And any responses that I need to send back to computer 2 will be encrypted using computer 2's public key. And again, it could only be decrypted with computer 2's private key. So you can see that this process, although fairly simple, is extremely effective in protecting our data as it passes over the network. In our next section, we will cover Secure Socket Layer, which combines certificate services with public key encryption.